Well, we're going to talk a little bit about using Linux, Module 1. What can I say about Linux? It's strange, it's abnormal, no one likes it if you're a Windows administrator. If you're a Unix administrator, you absolutely love it, and you hate Windows, right? It goes back and forth. So, Module 1 is about learning the file system, learning about the directory tree structure, learning about basic commands to get you to navigate through certain objects and certain procedures. Our objectives, I'm going to skip it because I got tons more objectives through there, but you'll pick up on what we're going to talk about. When we have a terminal session, okay, you have what we call bash shell, right? The born again shell. Have y'all been watching your videos? Y'all know what I'm talking about, the born again shell, right? It's called bash. All bash does is it'll give you the ability to change certain profiles to where when you log in, you can log into a GUI or you can log into text base. It will interpret commands that you give it, and then it will manipulate commands for input and output. In other words, certain shell scripts and things of that nature. All right, how many of y'all have actually taken Java? A couple of you? Recognize standard input, standard output, standard error, right? The three command type structures that Unix uses. Standard input, that means it is the command that will allow, or the file descriptor that refers to any input into the system. Standard out goes to the normal output, your printers, your monitors, things of that nature. And standard error is when you have a message or some sort of error in your system. Now, don't try to follow along with each one of the little submodules because I have this a little out of order. Okay? I don't want to make anyone confused. There's only 116 slides that we're going through. Okay, standard input is anything that you input. For example, I put a 0. Well, what is it trying to do here? Okay, there's three different file descriptors. I input file here or here. Okay, it's the etc. directory, the host file. I can either, if I incorrectly do it by just putting this, it'll come as an error. Or if I correctly do it, it'll give me the output that I'm requesting. Right? Pretty standard with any operating system. If you do something wrong, you get an error message. You don't do your honey-do list, you get slapped on the hand. Alright? I can redirect standard outputs and standard errors from the terminal string and put them in a text file. That's what we call the concatenator or the meta character of the greater than symbol. I can append or redirect that output to create a text file. Essentially a text file, even though there's not any extensions in Linux. There are some extensions, but we'll get to those in a little bit. Redirecting a standard input to a file is the less than simple. I take my input and I'm going to put it into something else. So remember, if it's an input, it goes to a file. File's going to be bigger than an input, right? The output's going to be bigger than the original file size, and so will the error. That's why it goes this way. Does that make sense? You understand what I'm saying? Should I draw it up on the board for you? I mean, be honest.
Draw it for me.
Okay. What I'm saying is, if I have a standard input, my input may be one line, right? But it goes to a text file. That file has bigger thing. So this is the easy way to remember. The little input goes to a big file. I have my file command, right? Now let me do it this way. I have my standard output or error, right? Which would be something big that I'm telling to go into a blank document. Now does that make sense? Let me move out of y'all's way so you can write that down. I just wanted to illustrate so you know the directions of the standard input and errors if you're going to put them into a text file. All right? And here's some examples of this. You have all these PowerPoints. So you can go back and look at this table. Now, notice this is table 7. In the book that we had prior to this class, it was chapter 7 when we get to this. So everything's bungled around. Yes? They're underneath the Content tab in D2L. All right. Pipes. If I want to send a standard output of one command to another command is the standard input, I can do so. By all I'm doing is putting the pipe symbol, which is shift, in the key that's right above enter. And what that does is I put my standard output on the left, and I can pipe it to a command on the right, and it will force all that command out there. So let's say I have a output from a program that gives me the result of 2, or if I have a program that gives me a in quoted command, I can output that to pipe it to this command and it'll run. I mean, there's a lot of things you can do. That's all it does. Standard output of here goes to the standard input of here. That's what we call piping. All right. We can use multiple pipes on a command line. So, I mean, you can have multiple sections of it if you want. You can filter commands by taking from a standard input and giving it to a standard output. And you can put them on either side of the pipe. It doesn't really matter. Don't make me yawn, Aaron. The T command will filter. It's a filter command that receives information from a standard input, sends it into a file, as well as the standard output. So instead of just having it go from the standard output of something to the standard input of a new one, of that new command on the line, it also adds it to a text file. Does that make sense? So if I use T instead of a pipe, now I've got 2 ways for it to go out. So I have my gator. And here's, you can do where you can pipe several commands. So the standard output of here goes to standard input of here, gets calculated, comes to the standard output, standard input, so forth, so on. All right. Pipes can combine redirection and piping. Input redirection must occur at the beginning of the pipe, where output occurs at the end of the pipe. Why is that? Because you have to have something to make something, right? So you have to have an input to pipe to something. You couldn't have an output without an input. The sed command. It allows you to replace certain text strings. You use all of it or some of it, depending on what you want to do. The awk command. It allows you to search the text for a specific action. So you can do awk -F and have several different delimiters that you want to do. All right. And here's some of the different ways you can do it. But like I said, we'll get into pipes a little bit more later on. I'm just trying to introduce you to it right now. Shell variables. All right, a bash shell has many different types of variables in memory. We have user, we have environment, and then we have special. Okay? Environment variables. Think of an environment variable similar to your desktop, your GUI. Okay? It modifies it and contains information about what you access most. Okay? What do you do? You have a user-defined variables. Your profile, if you will, from Windows. Your desktop settings. Does that make sense? And then special. If you're, depending on a role, or if you think about the RBAC access controls, your rule and your role based. These special variables are like that, in which you can define certain applications or certain things to run because you have that permission. Does that make sense? So those are the three types of variables. How do we do it? Well, we use set. I'm going to set something to do something. All right? A set lists environment variables and current values so that you can go in and change them if you want to. The echo command, all it is an output to the terminal. So when you're running a script and you say echo whatever this command is, it's going to print out all everything that runs in that batch file or whatever you had running. Changing the value of a variable, all you got to do is after the equal sign, you change the value. And we'll get into that when I start showing you, when we get into Fedora, we can go in and change environment variables and all sorts of stuff. We can change the home and the PWV, print working directory variables, but don't change them unless you're trying to freak Aaron out or something like that. He typed PWD and he goes to home. Okay, here are the common bash environment variables that we'll run into. Bash is the full path to the bash shell. So if I do path $equals, I'm setting my path, right? Same thing in Windows. What is a path used for? It is just a list of all the executables that you use most. Word, if you use a specific logon script, log off script, things of that nature. You can put those directly in there. You can even label it as a bash version. So you can say version 2.1. So I know that I'm keeping my versions in order. So when you get into change management, you kind of understand the flow of the process, right? Display, I can redirect the output of the X windows. The environment, the location of the actual configuration file is the /tilde-bash-rc. That's your environment variable file. Oh, I forgot my dot. The EU ID, or the effective user ID, who's using it at this time. History file size, history size. Your home, you can change the user home directory. You can change the host name, the login name, mail, operating system type. If you really want to have fun, change that. Path, here's that path variable I was talking about. The shell prompt, print working directory, random, shell, term cap. Those are term and term cap are your terminal variables. Okay, they're all listed in here, so you can go back and look at them. I'm just kind of giving you an idea. Variable identifier, pretty simple. It's just variable name, right? Can you create new variables? Absolutely. You just have to specify the variable name and then give a value for it. Okay?
Create a variable without a value, or it wouldn't work.
You have to have both. Now I can have a variable identifier where I set my new variable to a variable. Does that make sense? So the output of whatever would give it that value. It can contain all sorts of different types of characters, but can't start with a number. And typically they start with a capital letter to follow naming convention guidelines. Subshells. Most shell commands will run in what we call a subshell, because when you're in the GUI, you're actually in a shell. And so when you run terminal inside of it, you're running that in a subshell of the main shell. Did y'all realize that? Variables created in that current shell won't go to other shells. So if you want it to go to the entire operating system, you have to go back to the /tilde or .tilde-rc, the environment variable or environment profile. Export, y'all know what export means, right? You take something from one and move it to else. The environment command, or the env, shows all exported environment controls and user-defined variables in a shell. alias command. These are cool. I can create an alias, said Scott, and make it shutdown -H. And what will happen when you type in Scott, it's going to shut it down. Because my alias name of Scott is the alias for that command. So if you have a super long command, you can create an alias for it that may be 5 letters, and you just type it in, and you're done. Yes?
Is that pretty much for anything?
In Unix.
So like if you want to say format the hard drive real quick,
Uh-huh.
you can do it that way too.
Yeah, you notice when all the TV shows, when they're talking about hacking, most of the hackers, the good hackers, will actually have scripts already set up, and it's just a 5-digit character, hit enter, and they're just sitting here hitting these commands on you, and they're not typing out the whole commands, they already have it set up. Sorry, I gave away my secret. Chris back there is thinking, I should have done that before, if you hadn't already done it. Cannot confirm nor deny. When exiting bash, all stored variables are destroyed. So remember, bash shell is what's opened inside of your main shell. So do you want to change your environment shell? That's where hackers come into play. All right. Here are the environment variables that we're going to talk about. We have the ~/.bashrc. We have our etc. profile. We have our bash profile, bash login, and profile. All right. So, since y'all have all read your wonderful pages, what is the bash RC for?
Storage shell preferences for individual users.
For individual users. What about the etc profile?
Environment variables.
That is for everyone that will access this particular system. That's
So
the
like on the network, does that mean every computer on the network?
no, just this system. Because this is a file locally on this Unix box. If I edit this, it doesn't matter what user you are, you will have these permissions. There are catches to this, and I'll come back in just a minute. Then you have the bash profile. What is that? So it goes the exact same thing as the bash RC. It's for individual users. Then you have the profile. That's specific to a user for that specific computer. Does that make sense? Or of your desktop configuration settings. Your login and log off. They didn't put log off over here, but your login be your login script. Log off would be your log off script. Does that make sense? Yes.
So would that be like, you know, like when the administrator assigns you certain things that you're allowed to do?
Right.
You know,
Uh-huh.
you do the batch level.
And it'll be more like your network drives, your printers, things like that. And then I can have hidden different types. Now, logon shells are going to be used in a specific order. First, they're going to go to this overall system profile. If there's no configuration set, it will go to the individual bash profile, the born again shell individuals profile. Then if not, then it will go to the login profile to see if there's a login script that would have set it. And then if not, then it goes basically down to the profile. But it sets those in order of precedence. However, if this one's there and then this one's there, it configures that and then puts these configurations in. If this is not there, then it looks for this one before it goes on. In the first one of these that it finds a configuration for is the one that it puts in along with the environment. So you only get 2 of these 4. To add a variable, you want to add a line to the environment file, you're going to use command syntax. Any command placed inside of the environment file can have an alias creation. So when you're doing your environment to run specific things, that's where I put in my alias. Do it on the main computer, so if you're taking it to different locations, doesn't matter. All right? And the .bash rc is that runtime configuration. And it's going to be the first hidden environment file executed to log on. What's a shell script? Your own definitions. David. What would be a shell script?
Batch file.
Essentially a batch file. Basically, all it does is starts at the top of it, reads all the commands in order, and then prints them out on the line and lets the system run them. That's all it does. Hash pling. That's your first line in that shell script. It says you're going to use bash, X shell, S shell, BSH. It just says what shell you're going to run. Usually I just leave it as bash. Executing shell scripts with a read permission. I can start another bash shell as long as the shell has that argument that allows me to do so, if I'm a typical user. If you're going to execute it with a read exec, you can execute anything. Remember, if you don't have the permissions, you've got to be given the permission to run it. That's why we have to separate this here so you understand it. And if you want to, you can put an echo between it so you can see what's coming out. Do echo and then the command, and you'll see it printed out and stuff. Character sequences have special meaning behind the echo, prefixed by this slash character. You must use the -E option in the echo command for an escape sequence. What does an escape sequence do? It allows you to format your command. So if you needed a table structure or whatever, you can do that. You can make it beep, which if you do this, I'm going to fail you for the class. If you write a script and do the \A, I'm going to fail you for the class, just to let you know, especially if you put in an infinite loop. Had someone try that last summer. You know, you can do all sorts of different things. If you want to print a \, you have to do the \/ to print it. Okay.
Just like Java.
Exactly. Java is based off of Unix. So is C. So is C++. Actually, C and C++ helped develop Unix, or C did. Unix came off of C. But they're all based the same, and that's why you can run shells and all sorts of different things. Shell scripts maybe have a needed user input, right? Do we want to continue? Yes. To hit enter to continue. Read command takes the input from a standard input where you can. If I'm going to have just a regular user try to do it, I'm going to actually put in what they have to do, and I'm going to make it run in silent mode because I don't want any user screwing something up. Because 99.99999% of the time they will. Most type of construct is used in. A decision construct is the most common type of construct there is. All it does is flow control. Did this work, or where do I go? What it just makes it. It gives you the option, right? Y'all seen all of y'all have gone through at least the fundamentals of programming, know flow controls, right? Anyone not know what a flow control is? Okay. Here's a flow control. Program starts here, asks a question, yes, it goes here, no, it goes over here, ask another question, yes or no. Or you could also have multiple questions over here, depending on what your output is. Did it run successfully? No. It does it again. Or has a different type of command structure they can do. So that's decision constructs. With decision construct, we have what we call the if statement. How many of y'all familiar with the if statement? If I do this, what's going to happen? Or if, with an if statement, if this is true. Now, people want to say, well, if it's false, well, yeah, but the statement would be true because the condition would, you're trying to test the condition for it being false. This condition would be true, then you would execute something. And it always confuses people. But I hope y'all are better than that, right? I don't have to teach y'all the if statements. Okay, if that statement is true, it'll do these commands. Elif, not else if, elif. Elif. Elif, this is true. I always kind of make it an Irish joke. Elif, if this is true, then we'll do these commands. And if you just want to end it, then it's else. Okay. Remember, Elif is just making me just think of Frozen, Elsa, and Olaf. And the else statements are optional. Why are they optional? Because you may not need them. You can have an unnumbered or unlimited number of elifs. But when you're at the end of it, we have to do phi. Does anyone know why we do phi? It's the opposite of if. That's how you end the if statement in Unix.
So instead of if, curly bracket, curly bracket.
Yeah, it's just, you just if, whatever, then, and you, fi ends it. It also means finish.
What about nested if statements?
This is a nested if.
No, I mean, if you have another if within
Oh,
your else,
yeah, you have phi for the nested, and then it comes back out.
so you still have more fees than that.
Yeah. And then the condition also is the true portion of the statement. You can do tests, and you can use special characters. The not symbol, right, the exclamation point. But if you want to do an or or an and, you can't do an ampersand. And you can't do the double pipes for the or. You have to do -o or -a. And it has to be lowercase. Unix is case sensitive. I can't tell you the number of times I'm going to run in, y'all are going to run into the problems because you have caps lock on or do something wrong. And the test statement that you're using to do a test condition has to be inside of square brackets, and the quotes have to be before and after those brackets to do your test. So what you're going to see because you're actually creating the character with a bracket. That's why you have to put it in the quote for the test condition. And here's the way you do it. And again, this is also in your PowerPoint, so you can go back and look at it over and over and over for testing conditions. Here's even more, where A equals B or C equals D. Okay? Case statements. The case, the variable is in this pattern, which will be 1. Then you will do this, and then you finish it out with the 2 semicolons. That's the end of that case. And you keep doing. And again, ESAC. What's the end of case? Case backwards. I think Linus Torvald, when he created Linux, was a little drunk. But it also means escape. You're escaping the case. So if it doesn't meet any of the criteria, you escape the case and keep going. If a match is found, it goes to that whatever the command is that's in that case. Otherwise, it will end with the escape. Time-saving shortcuts. You need to do your ampersands or your ors. Only if it's a command, not a testing condition. The second command here will execute only if this one doesn't work. I'm sorry, if the first one does work. Yes?
Could you put that in a shell script as long as it's a command,
Mhm.
not part of some if statement?
Yep.
Okay.
Loop constructs. They execute commands repetitively. As you know, loops continue to go and go and go until there's an end. Right? Don't want to get stuck in that infinite loop with the beeps. For example, for whatever the variable name in this string, do these. Notice this is different than Java, right? And then you have done once you're done with that for loop. The while that condition is true, do these. Then I'm done with that loop. All right? Basic Linux usage, shells, terminals, and the kernel. Let's take a break for a few minutes. All right, we're going to talk a little bit more about basic Linux usage, shells, terminals, and the kernel. What is a terminal? Well, basically that just allows the kernel to talk across the network. It's a command line interface. The shell is the user interface that allows you to accept and transfer data to the kernel. Our default shell nowadays is the born-again shell. However, there are multiple different types of shells. We have the X shell, the S shell, BSH, which is the born shell, and Bash is the born-again shell. It's the enhanced version. You have several terminals that you can use. You can use terminal 1 through 7. You'll specifically use in the lab 1, 2, and 5. 7 actually takes you back to the GUI. But this is how it works. You can have a terminal that's inside of a shell, which is inside of the kernel. That makes sense? You have multiple a terminal inside of each shell. The graphical user interface is on top of the Bash shell. In other words, your GNOME or your KDE environments. Here's what you really need to know when you're at the command line on a terminal. If you see a pound sign out to the last character you see, that means you're in a privileged mode. Same thing for Cisco IOSs. You're in the privileged mode. In other words, root. You're an administrator. You see the $sign, that means you're just a typical user. And if you wanted to jump up, you'd use the SU or super user do command, which is a sudo command, which we'll get to later on. Here are your 7 terminals. Like I said, you'll use 2 through 5. You could use 6, but it's usually used for something else. Terminal 1, Terminal 7 will take you back to graphics. You know what the neat thing about this is? Think in Windows. How many command prompts can you open at once? 1. Then it pauses one to open up another one if you're running a batch file or something. So I can do it in memory. Here I can have 2 through 6 running on the same shell. And this is just how you get into it, but we'll get to that later. Remember, all commands I told you earlier are case sensitive. Specific letters starting with a dash appearing after the command name alter the way the commands work. In other words, when you see your option, you have that dash, whatever, SF, any of the ABCDs or 1, 2, 3s, that is an option identifier. So you have like PWD space dash whatever. Y'all know what I'm talking about now? Instead of the slash in Windows, it's just a dash in Linux. And then you give the argument of to whatever you're stating. Here are just some basic common Linux commands. Clear will clear your terminal screen. So if you get too much information and starting to get things, just type clear. It clears everything off. Reset will take you back to where you reset in that specific terminal. And one thing I'm going to have you do is we'll get you into 2 different terminals. The first terminal, I'll have you log in as root. The second one, I'll have you do commands, the exact same commands in a user one. You can bring them up side by side and take a look and see what the difference is. Finger, all it does is just put the information about the system user on the screen. Tells you who you are. Who says who all the logged in people are. So if I go into a terminal and say who, it'll tell me TTY2, this user, TTY3, this user, TTY1, this user. So it can tell you who's logged in at where on that machine. Who am I will display your specific login information. ID gives you your identifiers for your users and your groups. Date, obviously, is the date. Cal for calendar. And then exits you out of that terminal. Okay? Meta characters or something, or characters with special meanings. A $sign means variable. Okay? So path, $sign. Right? Or I should say $sign path, because you're declaring the variable path. And here, special home directory variable, the background, command execution, command termination, input output redirections. The pipings, wildcards, they're all right there. Like I said, they're in your PowerPoint. Getting command help. If you need help on a certain object or item, you can type man and then whatever the command is, and it will bring you up a manual of that page. And that manual will give you in-depth information about that command. 90% of that man is on here. I've already been nice enough to make sure that happened for you. Yes?
So on all these command lines that we put in and stuff, is there, because I know there's thousands of them, you know, is there a place you can go where you can print out
Google. Google, I don't know a specific website, that's why I said Google. I'm not trying to tell you to go research it, but I just don't know. If you type in Linux commands, they're probably just going to give you a basic list. If you want to know all the Linux commands, type man and go in there and look for them. Getting help command, this will tell you all the sections of each manual. Yes, there's at least 10 sections in each manual. And they don't really tell you if there's specific ones or not. If there's nothing in there, then it'll just say not applicable to that command or whatever. Directories. Y'all familiar with a hierarchical directory tree structure in Windows, right? It's the same idea here. The top level directory is just a slash. That's the top level directory here. That's what we call root, the root directory. Now I'm not talking about root's home directory. It's the root directory is just slash. So be very careful when you're taking a Unix Linux Plus test and it says what is the root's home directory? It's /usr/home/root. If it's asking you what is the root directory, it's just slash. Guarantee you're going to see both of those questions. All right. In Windows, you had C, then you had Windows directory, and had a folder. You could have root and system and color and all that. D, you could have data, etc., home, Mary, Bob, Sue, right? Well, under Linux, you have one called the root directory. Like C is your root directory. You have Windows, root, data, etc., home. Home would be where all your the C:\users is just /home. See the comparison? I thought about coming up and typing out some of these comparisons to make it a little easier for you. Someone email me and remind me. And what I'm going to do is I'll go through the Linux hierarchy and break it down for you. Home directory is going to be unique to each individual user. The tilde meta character is used to refer to the home directory. So when we're in the command line and it says user and then it has a tilde, that means your user home directory. And I'll show you all that when we're walking, or when we're going through this. Print working directory is PWD. All that does is say, tell me where I'm located, in case you don't know. CD, you're going to change directory. That's just like Windows, right? I change my directory to this. Now, relative path name is just a pathway inside of the directory in which you're in. You can give a relative path. If you're doing anything outside of that internal directory, you need to give it its full path name. Okay? If you're going to do your parent directory, it's not cd ... it's just ... Your subdirectory is a directory that resides in another folder. Pretty self-explanatory, right? Tab completion is something that you don't have in Windows. Anyone know what tab completion is? I can have 3 letters and hit tab and it'll complete my command for me. Text files are readable text that you can see in any editor. Binary data files are stored and associated with executable programs. Directory files serve as placeholder for other files. Linked files are just associated with another file. So part of the information in this is linked to something else. Special device files represent system devices. Named pipes identify a channel that passes in between processes. We'll get into this when we start looking at the command structure inside of it. So don't get wrapped up with the small definitions yet, and I'll explain them. Socket files allow a process on another computer to write a local file. All right. File names in Linux can go up to 255 characters. Same as Windows. File name extensions. Identifiers follow the dot at the end of the file name. Most files in Linux do not have any extension. So you didn't have the 8.3 problem. Anyone know what I'm talking about when I say 8.3? You had in Windows 95, you had 8 characters dot your 3 character extension. You had a total of the 11 characters, well, 12 characters. That was all you could have for a file name. Linux got rid of that so they could actually have 12 character name. But now they have 255. So one cool thing about files, if there's a dot in front of it, it is a hidden file. I could have Scott and dot Scott. The dot Scott you wouldn't see if you ran your ls command, but you would if you would just see Scott. And then here's some of the common extensions. You notice I told you about C and C++. Then here are all the compressions and Perl scripts like I was talking about on Tuesday. The ls command all it does is list the files in a directory. You can do a -F that indicates the file type. -I, I'm sorry, -L is a argument to the long list. In other words, give me everything about the information, detailed. When you do your detail in Windows, that's what it would give you. Long listing gives you 8 components, gives you the file type character, the list of permissions, hard link count, the owner, the group owner, file size, most recent modification, and then the file name. Like I said, the details. If you do a shortcut for it, is ls.l or -L. Displays the file command, displays any type of file. Hidden files, like I said, start with a dot. If you want to see those, you got to do ls-A, which says show me all. All right. It's short. Instead of going --all, you just do -A. And just, like I said, these are all in your PowerPoint. You can go back through them. Wildcard meta characters are used to simplify the commands. All they do is they match the entire file name and the portions of the file names. And they can use them for Linux command system file names. Wildcards are pretty cool. If you don't remember the rest of it, you just hit star. If you're looking for one character, you can do $A, and it'll bring all the commands with A in it, or A question mark. If you do put it in bracket, it'll do AEGH. It'll look for everything that is either an A, E, G, or H. If you do A through E, it'll look for everything that's A through E. And if you put the not in there, it'll look for things that are not A through E. Pretty simple, right? Concatenation is the cat command. Cat -N, what it does is it'll display the line numbers and the contents, but if I'm going to cat something, I'm putting things together, right? That's concatenation. What is tack? If you really want to have fun with someone, run tack. Puts everything in reverse order. Don't ask me why you want to display the contents of a text file in reverse order.
That's what I was going to ask. When would you ever be applicable?
When you're reverse engineering something.
Good point.
Head will take you to the top 10 rows. Tail takes you to the bottom 10. And then you can do a dash and say 5, or if you want to only view the 5. Large text files can be using the cat command because only a portion of it will fit onto a screen. I can do the more, which will go page by page, or I can do less, and I can just scroll down. You can use, if the output is too large, you can use the pipe meta character and then put more or less, and so you can control what you're looking at. All right. You really don't use binary to look at it. You can use the OD command to look at it in octal format. It's going to give you base 8. And if you do the X, it puts it in base 16. But you can't read it, so what's the point? All right, regular expressions. They're text wildcards that ease the search for specific text. They look for the pattern of text. And they use text tools such as Emacs, C++, Perl, grep. We're going to do a lot of grep in here. Find out grep is the easiest. Different from regular expressions differ from the wildcard expressions. Why? Wildcards are interpreted by the shell, whereas regular expressions are done by text. Okay. Wildcards match characters and file names. Regular expression does it in the text. And they have different definitions. And there are more regular expressions than there are wildcard expressions. You have common and extended type of regular expressions, and here's just some examples of them. I'm just going to go through these, go through that later when we get to it. grep, it's what we call global regular expression print. It's a command that displays the lines into text file that match to common regular expressions. egrep displays lines in a text file that extend in regular. You write that as grep-e, and if you don't want to interpret it, it's -f. -f is faster. grep requires 2 arguments. It requires that you have a text to search for and the file name. Kind of makes sense, right? Because it's a text expression and it has to have a text file to look, and then you got to tell it what to look for. It is case sensitive, but if you want to do insensitive case, then just do -i. Now we have text editors. You have VI, or Vim. It is the worst text editor. You can do very little with it. It's portable, not reliable, and not usable. You have 2 possible modes. You have command mode and then insertion mode. That's it. Command mode allows you to execute it. Insertion allows you to enter data into it. And that's it. Very, very, very tiny. Here's your commands. That's it.
So is it like rarely used?
I rarely use it. Most people don't even bother with it. It was before there was other ones that came out. This is the only thing you could do to write scripts and things. Like I said, those are your commands for it. I mean, they're not really commands; they're characters. Emacs is comparable to VI. It does more list. It's called for list processing. Emacs is not easy to use, and it's better if you run it in the GUI version. So when we're editing our files, we're going to use Emacs, but in the GUI version, just to simplify the course for you. And that's where you can do your Control A's, Control C's, Control X's, all those type stuff. And that's what Emacs is going to look like. It looks like Notepad, doesn't it? That's what it is. It's more of WordPad, though. We may also use Nano. It allows you to do the control combinations. And it's very basic and easy to use. And if you're trying to modify something real quickly, you want to use Nano. gedit. I like to use this one as the graphical, it's our graphical text editor. I like it better than Emacs. It's more of your Notepad, WordPad. I mean, we may use Emacs, but I'd like to use gedit in the GUI, make it a little easier. Yes. Do you have a question, Kristen? Okay. And there's what that looks like. Looks very similar to Emacs, doesn't it?
Very simple.
Sorry, summary slipped in there from that part of the lecture. File hierarchy standard, FHS. Now we're going back into the hierarchy. I told you these are going to be bouncing around on you, so please just bear with me. I'm not trying to confuse you. File hierarchy standard is just a standard of directories in Linux and Unix. And like I said, when I get that email, then I will go ahead and give you that hierarchy structure between the two. So those of us that are Windows people, you'll be able to figure it out really quick and adjust to where the different home directories and things of that nature are. And I actually had a document that compared Linux commands to Windows commands. And I'm trying to locate it because if I can, it'd be kind of cool for y'all to have. Because it'll make it a lot more sense to you. Here's some of the directory structures: bin, boot. These are all your typical ones you're going to have. This is your mounting. That's for any time you're having to mount a device. The /dev is not development. That's for your devices. That's when you're adding in hard drives or CD-ROMs or flash drives and you mount them. They're going to be installed in this dev directory. And I'll explain how that goes a little bit later on. Your user locals, your users, your variable structures. How do you make a directory? mkdir, right? Same thing here. In Windows, move is MOVE. Here it's just MV. You have to have the minimum of the 2 targets. You have to have the source and the destination, right? The cool thing here is it can be absolute or relative. You can also use it to rename files or directories, unlike Windows. Copy, instead of COPY, it's just CP. It has the same arguments as the move command. I can do recursive copying, which I mean just use the -R. And all it does is recursive search in all directories to make sure that there's nothing else in there. If I want to do it in interactive mode, I can do it with the -I option. Or if I want to do a -F, I can override that and say I'm going to force you to do it. Remove. How'd you remove stuff in Windows? Anyone remember?
Del.
Yep, the old delete. Here it's RM, remove. /F to override. I want to remove the directory. RMDIR. You catch it on? Pretty simple, isn't it? And there are your management commands. If I want to locate a file, I can search with doing grep, right? I can receive full or partial names as an argument. I can do find, and then whatever I want, whatever criteria. Put the wildcards in quotation marks. And if you know what subdirectory it might be in, then just add the subdirectory, because it'll speed up the search. And just don't do it from the root directory, unless you plan on spending a few minutes. And here's some of the common criteria. Search for files that were accessed less than so many minutes ago. And what I may do is pull some of these down so that you can actually go through and look at them step by step. They may or may not be in here. Our path variable, like I said at the very beginning, I told you we'd come back to this. A path is a defining of a list, a variable list of all the executables that you want to continue running in your environment. So that I don't have to write out the whole path name for it. I can just type in explore.exe and Explorer would come up, because Explore C:\/ Windows or WinNT / Internet Explorer or Microsoft / Internet Explorer -IE.exe or iExplore.exe. Instead of having to type that whole thing in to get it to run, I can just type explore or iExplore.exe or just iExplore and it will pop up. That's what a path does for you. It just keeps those paths already. Those are the first thing it searches. How many are familiar with the local host on Windows machines? The local host file? Basically a local DNS where you give it a name and it goes out. Path is very similar in that structure, that a path has a list of all these relative paths, or I mean full paths to get to certain executables. And that is the first document that it searches to find that location of that file. And if it doesn't match the path, then it says file name or not found, right? That's what path does. It's just a quick reference. Linking files, that can be symbolic link is one file as a pointer or a shortcut to another, versus a hard link, two files that share the same data. And I'm thinking that the other set that was there just got put in the middle of these by accident. Just by the way it went from linking to something else back to linking. It just seems that way. File system has three main structural sections. It has the super block that contains the general information about the file system. It has the end node, which is several end nodes which describe the file or the directory. Then it has data blocks, which are the data files themselves. So you have your super block, your inode, and then your data block. Right? Everyone is still awake? I haven't put y'all to sleep. Hard link files share the same inode, and inode number. Okay? To remove a hard linked file, delete one of the linked files first. What it means is, if I have two different files that have inode, this is very similar to those pointers that we talk about in Windows where it's pointing to files that are in different locations. Same idea. The data is recursive in these because of this inode number. Alright, and I'll show you all how to look that up. Symbolic linked files do not share the same inode and inode number with their target. Symbolic link is just a pointer to the target file. If the target file is deleted, the symbolic link goes away. It serves no function. Here's a symbolically linked file. Notice the inode numbers are not the same. In the link command, you have two arguments. You can link to an existing file, and then you have to have the target file to create the link to. So you have to know both files in order to do it. And if you want to make it a symbolic link, you just add -s. Interpreting the mode, user is the one that owns that directory, or owner of a file or a directory. Owner refers to users with the ability to change the file or to the directory. Other refers to anyone else that's on the system. And permissions are not additive, meaning that an other is not going to just arbitrarily get more permissions if he gets added to that file, or that file he's not going to get the folder. Or if he gets a folder, he's not going to get a file. They're not additive. So let's take a break. Alrighty. We're going to log into vSphere. You should have it on your desktop.
Fred, I don't, sir.
Huh?
It's not on either of ours, but admin.
Okay. If you go to Start,
Yeah.
All Programs, VMware, you'll have the vSphere client.
Bam.
Everyone got that up so far?
Is that the same one you can get on the Microsoft website?
The client, you mean? Well, on the
VMware.
yes. Well, this is vSphere to log into our vCenter. All right. The address is vc.cyber.rose.edu. Your login is going to be your first dash your last name dash RSC. I'm special. I don't have RSC. If you have changed your password before, it's whatever you changed it to. But the default password, is password 1.
Your first name dash last name dash RFC.
Yes.
Unknown connection.
Did you do vc.cyber.rose.edu?
Oh, I did that later. Oh, .edu?
Yes. vc.cyber.rose.edu. And when you first get in, it should come up to a screen looking something similar to this, except I have a little bit more options than you will. Well, I'm an administrator. I'm not the administrator. I am a administrator. I only have certain permissions. Let me know when everyone's in. Chris, you know you didn't have RSC on yours. You don't have R-RSC. Oh, do you? Okay. I'm trying to remember. There's someone in here that didn't.
Didn't have what?
RSC after theirs, but
I don't.
is it you? I'll change it just to make you mad. All right. You'll go over here where it says VMs and templates. You're going to have a much shorter version, but you'll go to Rose Labs, down to Schools, to Rose, to Unix, Linux. You'll go into your specific name, and then you will right-click, and then we have a two-step process here.
Right click on Fedora.
No, right-click, yes, Fedora. The one that just says Fedora 18, not the Fedora 18 ISO, yes.
When I logged in, mine came up with a totally different screen.
All right. What we're going to do on Fedora 18, I want you to power it on, right click, and then open console. And you should get to this little screen that says Start Fedora. And go ahead and start Fedora. And I can tell you the rest of the people that are on VMs right now are going to be mad at us.
Yeah, it's slowed down so much.
Well, because I kicked everyone up to 4 gigabyte of memory
Oh, did you?
on this instead of 512. Everyone else has all their images are 512. It's because this version of Linux doesn't like to run on 512. So this particular image should have 4 gigs for you.
I'm really pissed off to stay logged in.
Yeah.
Don't power down.
I mean, he only has 19 terabytes of, or 1.9 terabytes of RAM, so it shouldn't hurt too bad. All right, everyone here? Everyone's there? Do what? Oh, is it still starting? Okay.
Oh, I know, I'd like to, I don't like it to fill it.
Just let me know when everyone's there. Click on Live System User. And give it a minute. We're going to install it on the hard drive. Don't ask me why it keeps asking me to do that. May have to re-image everyone's drive.
English.
And then just continue all the way through. Yes, I want to install it on that disk. Standard partition. What is going on? Okay. Leave it on LVM.
Installation option, partition.
LVM. Yes.
So the distribution that we're using is called Fedora?
Yes.
Okay, so if we wanted to do it, we'll do it at home.
You can log in from home to play with your VM.
You do that through the test app or?
I'll send you, put out instructions.
It's okay to do this from home?
Uh-huh.
That's cool.
That way you get more practice time. And
Yeah, totally. And you were saying the test out ones are kind of generic, right?
and this gives you an actual machine. You can go and do whatever you want to with this machine. I'm not going to. If you screw it up, I'll teach you how to do snapshots. And so
We don't have to do it each time we log on. We don't have to do this.
this is the third time I've had to do this. So I'm going to look at it again this weekend. If it has, then I'll just re-image everyone's before next week. Because I don't want us to have to do this.
That'd be a pain in the butt.
Because it's like every time I shut it down, I have to come back in and do this, even though I've done a snapshot of where I'm at. So I'm going to try to do a different snapshot and see.
On shutdown or restart, are they pushing an image each night to these machines?
Mm-mm.
That's the only way we do it.
Unless the what it's looking for to install from is an ISO, and it's just going back to that ISO to pull in for the hard drive every time, instead of a folder.
That's not really efficient.
Now this is taking longer than it has before, so I don't know.
You're going to win.
What?
That's his face. He knows.
With the secret ones.
Oh,
Yeah. It's like salty. But I like this. That'd be awful to have.
All right, all right. Basically, this is what I wanted us to get to tonight anyways, to get into the system. Because you're going to end up installing it anyway as part of one of the labs. So I'll have to figure out what's going on, because we shouldn't be having to install. It should have already been installed for you. Because I sat there and did it 3 times. 2 or 3 times in my office. So I may just go back down to Fedora 13, since that's the other image I have.
It just looks like it just keeps pushing a new image to it. It doesn't include the install.
Because it says from live medium. That's what makes me wonder where it's coming from. So,
Since this is done under our student names, are you able to save it at this point?
even if you did, I mean, I'm doing, this is underneath essentially my name, but the it's not saving for me either. So you're right, at this point, it's not able to be saved. Normally when you power down these VMs, you can pick up where you left off.
Yeah.
Basically, you can not suspend it, but I mean, when you shut everything down, you've got everything saved, it's saved. You can, if you screwed something up, it's going to be there when you get back, kind of thing.
So are we using the same VMware on that admin?
Are we going to be able to reset the image on here if you can get the install to hold?
Yeah, well, once I get the install to hold, you mean to reinstall the
Yeah,
image?
see if I screw something.
Oh yeah, that's why we're going to do snapshots, and then we can.
Okay. That's something.
What I want to do is I want to see, because I want to come up here and I want to take the snapshot from here, and see, log back in and see, because what I did is I closed it out then redid it, so I'm wondering if that was my problem, as I took it after.
Could just be the boot device.
But it wouldn't account for all these machines, though.
Yeah, that's what I'm saying. I don't know, but if I, well, all y'all were clones of mine, so.
You were able to reboot it before, right?
Well, when I rebooted, it came back to doing the exact same thing it did when I first tried to install it.
It sounds like it's booting from the exit.
Yeah, and that's what I'm saying. If I take a snapshot here, then we start at this snapshot, then I don't have to worry about it. And we'll just always revert back to that as the baseline snapshot. Or I can also create a VM off of that snapshot, and then that would be the one that I would forward to everyone, so we don't have to go through this process again. But hey, by the time this gets through, y'all have installed Fedora.
Yeah.
What do you think of that?
Pretty cool.
You didn't realize you were going to get that far today, did you? By the way, that's module 2. So we're 2 weeks ahead. Yes.
So I was gonna ask you this, VM center, are we using this in the,
I haven't decided yet. I won't know any of that until probably later on. I'm planning on getting the rest of my fall classes set up first, and then because I got some time before NetAdmin, you're gonna be doing the test out, and I'll tell you what my final things that I want. I've just got a lot of work for fall classes because I'm teaching essentially 3 new lesson plans.
just trying to get a little bit ahead.
You can go ahead and do them all, and then I may just give y'all an image to play with for 2012 and give you a 2008 image to play with. I might just do that. I don't know.
Which, I mean, the Windows Server 2008, that's the one, I've worked on.
You're faster than me. Your little hamster's running too quick. I'm gonna have to give you a ticket. I can give you a ticket, all right. You what?
Oh, we were talking courthouses. I used to work at the court clerk's office in Oklahoma County in the criminal department. You were talking about jury duty, and I was saying basically just runs people's lives. But no longer.
Why not?
I don't like managing people. That's what I had to do. They kept on promoting me. I discovered I don't like the public and managing people, so I'm out. I serve tables and do this now. My job is like keep crackheads myself. Yeah, people work there sometimes.
What do you want us to do after it's been installed?
Did it install for you already?
It was for a while. Or is now successfully installing your system?
Okay, then just hang on. I'm waiting for it to install, then I'll tell you what to do. Yeah, that's 90% of this class is sitting and waiting.
Been in some classes, but that was pretty much what it was.
Well, that's all my classes, right?
Especially routing.
So is that mobile device you're teaching? Is that a new one?
Well, I taught it last fall. Then we didn't do it in the spring.
Because I know forensics touched a little bit on that. So is it the same thing?
No.
Totally different?
I'm looking forward to that one. That's gonna be cool.
I have devices that y'all can actually get in to play with.
Yeah, I heard you bought some. You had some new toys.
Oh, I have all sorts of toys. And I have I bought a couple pineapples, and then I've got some rubber duckies coming in.
So the pineapples are like a Wi-Fi clone, right? Like they trick you into thinking.
Evil
it's
twins,
the
yeah.
internet, Yeah.
So basically be very wary with your mobile devices walking around here.
You better be very wary of me, period.
Hey, you better be nice or I'll stick Eileen on you.
I'm not afraid of her. Right?
Professor, after this finishes loading, what do we have planned?
Once I get it done, then I'll get to that point.
Alright.
Is yours done? Where you at? Bad. Mine's done.
We're gonna take the snapshot of it, and then that'll be the end of it.
Well, I think I'm fastest runner in this entire. Actually, I have seen you. Yeah, I've seen you on the trail.
Oh my gosh.
You're a viewer.
No, I did the elliptical.
Okay, which way is it? So
It's too sweaty.
You lost.
That's terrible.
In what?
water
Yeah,
laws.
it rained like
In what?
Solid range jury duty. Interesting.
I represented myself, and I won a case.
Which courthouse?
County.
County, yeah. It's almost impossible with the feds. That's where my wife works.
I had someone hit me behind. Her insurance company didn't want to pay for my medical. I went against their insurance lawyer and won. And it was kind of funny. I slammed that lawyer against the wall. You know how lawyers like to ask 6 or 7 questions all at once in the same sentence? I stopped her right as the first question. I immediately answered it. And it was getting her frustrated. And so she kept doing it again. I stopped her again. And the judge goes, "Will you let her ask her question?" I said, "Well, Your Honor, and please the court, I'd like to put into evidence something. As a certified public instructor and a professor at several colleges, it's evident to me that this individual does not know grammar, so I'm going to go back and revoke her grade in English Comp 1 and Comp 2 Therefore, it's now impossible for her to have her Juris Doctorate because she couldn't have her master's degree, which she couldn't have had a bachelor's degree because she couldn't have completed Comp 1 or Comp 2 because she doesn't know a single sentence structure. And the judge fell laughing. And he goes, overruled.
What judge was it?
Gray, I think is his name.
Gray, yeah.
Uh,
He's dead now.
he was an older guy.
He's for sure dead.
Huh?
He's dead now.
Is he?
I think so. Judge Black and Judge Gray died recently.
Huh. I'd have to look on the site.
Yeah.
It may not have been his name.
They have like 20 something of them. There's a lot.
Yeah, this one. But he was just laughing. And just at a time that she couldn't say anything after that. And I came in there and I showed case law where even though it's less than it's a 5 mile an hour impact, you can still have trauma that occurs. And even though there may not be any quote unquote physical damage to the car, and she was saying, well, there was no physical damage to the car. So I said, so what's this $500 check for replacing my bumper from your insurance company if there was no damage to my car? And the judge sided with me, and I got $2,600.
Cool. And the lawyer didn't get 33% of that.
Nope, all me. And I went and paid my debt, and that was the end of that. So I ended up getting like $600 out of the deal, and then she had to pay me the court costs back. But and I was so nice, I sued her on the last possible day that I possibly could for statutes of limitations. I filed it, and she got served on that last day. 2 years after the incident.
That's cold.
I gave her insurance company 2 years to fix the problem. They refused to do so. They paid. Now, I could have gone to and got an attorney and probably won millions of dollars, but that's just not me. That and I was a PhD student, and research is my thing. I love to research, especially law. So I don't want to go up against law.
If you go for the big bucks, do wrongful termination. Average payout is $400K, something like that.
Oh, I could have filed against ITT for discriminatory actions and all that stuff. To me, it's just, I will threaten the litigation, and that's enough to scare people in. I've won a, what do you call those cases? Arbitrated cases with the Air Force. I beat them at their own game when I left Tinker.
So you were in JAG court?
No, I was a civilian, and my management and my organization broke 38 federal discriminatory laws against me. And I nailed them to the wall. And they go, well, you can't take this leave and this leave and this leave. And I said, oh, really? As a federal employee, I'm entitled to FMLA just like every other individual. I'm entitled to my annual and sick leave just like every other individual. But I also have an exception. Being a service-connected veteran that has greater than 10% service connection, if I'm going to a medical appointment or if I'm out due to a service-connected injury, you cannot terminate my position. And they tried to terminate me because I was out with a medical condition. So I nailed them to the wall on that. But all sorts of fun. I think that this bar on here has a little bit of a problem. It's not adding up correctly.
Mine kind of crashed after we got done with the bar. Now it's just kind of black.
So no.
Oh, it was crashed.
Yeah, no, it really did.
Yeah.
Same time for this, that's all.
All right.
Snapshot. So close. You can do it. Just because we're trying to install at the same time.
Probably. So tell me, how many of y'all learned anything tonight?
Yeah, I actually did.
Oh, darn it, I forgot to give you my spiel
Spiel.
on Tuesday. One thing that I highly encourage all my students to do
You're done.
is
It won't let you move at all. Oh, to go to active, okay. Right.
And how do you move it over so you can, click that button that's there?
I hit tab.
Okay.
All right.
That didn't work.
You hit tab twice and then hit enter.
Oh, okay.
That prompt you for the root password?
Just make up one. It's not a week.
It's not a week.
Hit tab twice.
You said just make up one?
Do what now?
You said just make up one?
Just make up whatever you want your root password to be.
How do you get it over there in tab?
Hit tab twice and then hit enter. You're not going to be able to see it.
Got it. Your password, anything you want?
Anything you want, just as long as you can remember it, and it's not a weak password.
Just the password.
It won't work.
No, that's what he.
That's what I tried too. Nope. All right. Everyone got to this screen now, right? Well, with the exception of my little take a virtual snapshot.
Oh, yeah.
Okay.
Yeah, just the blue screen.
You see this first blue icon up here? Right here? Click that. It's going to bring here to take a virtual snapshot. You're going to call this finished install. Then you'll just hit OK. And now we have a snapshot of where we're at. And while it's taking it, you can't suspend it, you can't stop it. It's
Just do finish.
Did you get to that snapshot again, sir?
right here.
That one, thank you.
It'll take it a second.
Just do the snapshot.
When you get back to a straight blue screen, then you can take the snapshot.
Which icon is that? More the, range?
Yeah, and then do, finish the install.
Take a snap, yeah.
That's the one.
Will something else pop up to tell us that it's done?